First up is Kevin Keller. He's Managing Director of K2 Kinetics that has offices here in York and in Long Beach, California. Kevin began his career in the consumer goods manufacturing industry with the 3PL, and his career has advanced to be working with major Fortune 500 companies. He held a leadership position in packaging system engineering group and supervised projects up to $10.2 million. As a founding partner of K2, Kevin is now focused on integrating robotics and technology into packaging systems. And today, Kevin will be discussing how we got to Industry 4.0, what it means to manufacturing, and what opportunities exist to leverage those technologies within your business. So, without any further ado, welcome Kevin.
Thanks everyone, good morning. Try and drive this thing here. So, pleasure being here. This is my first summit. Thank you to NewTek and good morning to everybody. As Andy mentioned, he called me probably months ago and said, hey, do you want to get over here and talk about some interesting stuff that's happening? He knows I'm pretty big into technology and et cetera. And I said, yeah, let's go ahead and chat. What's the whole summit thing about? And then here we are with a room full of people and a whole day's worth of sessions. So pretty exciting stuff. I'm going to talk about some, obviously the big topic of I 4.0, we'll tag it as. We have about 40 minutes to talk about this. So who in the room, let's do a quick show of hands, who in the room is familiar with the subject Industry 4.0 and like what it's about? Man, you guys are motivating me. All right. Okay. It's funny because like I get inundated with information every day in my email about IoT 4.0 and all that stuff. So if you ever see any blogs and anything, I can even like get everybody's email address. I'll send you some information. But a little bit about myself. I'm Managing Director of K2 Kinetics. Expand on what Andy said, but I started the company in 2011. I was with some smaller 3PL companies. Ended up going into working for the larger Fortune 500 companies, and just needed to shift the pace and decided to go out on my own. Started K2 Kinetics, which is focused in packaging systems. We do also do work in medical process, some light industrial, etc. But 60+% of our business is in food and bev. We have offices in Long Beach and York, Pennsylvania. You can almost throw a football to our office, which is probably right through the woods that way. Been in business, like I said, for 5 years, and continue to grow and have an amazing, seeing the world change right now is awesome. Like where we're at today is like, this is where I want to be, and we're just at the beginning of this big cusp. I'm a big fan of Elon Musk, and to Andy's point, Elon would say, he wants to die on Mars, just not on impact. He also makes some pretty interesting comments about, we have to move the needle. Like, I don't know where everybody's at in their kind of like in operations, et cetera, and what like is driving down from the executive level. But today is about we definitely feel at K2 that like we need to make big change, and we're going to come in with some crazy ideas. And some people might say, yeah, you're crazy, and they'll push us out the door and all that stuff. But that's who we are, and we're conveying that. Like, change has to move the needle, and this says it all. I think is like some people don't like it, but if you want to, you need to embrace change if the alternative is disaster. We're not saying that a Hershey's is going to go out of business or et cetera, but there are companies out there that if they don't change, they're going to be overswung by these smaller entrepreneurial companies that are coming in and supplying stuff. Like, for example, this phone, it's unlocked, it's got 6 gigs of RAM, it's a great little product. It costs half the price of an iPhone. It's a startup company out of China. Where are the other iPhones being made? China. So like similar products, and these guys are killing it when it comes to getting into this very tough world of consumer electronics. This is a slide that or an image that's heavily overused, but I thought everybody would have seen it 100 times by now, but I'll talk through it. You know, I 4.0 is about, you know, revolutions and technology changes and all this stuff. Everybody's familiar with the first industrial revolution, mechanization using steam, water, etc. Late 1700s, hey, we can now make, you know, improve these factories and have like gross manufacturing. Then Henry Ford and his team, you know, basically took it into the late 1800s. We had mass production assembly lines. You could have any Model T you want as long as it was black, and it was this, right? So, and he punched them out and created what we call like battleship lines. These lines that just like produce, not flexible at all, but you know, he had to get something to market and for the right price. Then the timeline for the third generation of revolution, it's, depending on where you read, it's like late 60s to maybe mid 80s. And late 60s because computers, you know, when computers were released, these, you know, all this technology is like getting out there and people were like, yeah, we're gonna have mainframes, we're gonna do all this stuff, etc. I say late 80s then because you start talking about, you know, actual industrial arms. When industrial arms came into the manufacturing space, you know, what they were all about. So it's, some people nowadays say we're actually truly in a 3.5 world in which, you know, there's just a shift into 4. The fourth takes a version of 3 and connects it. And it connects it through something called CyberPhysical Systems, so CPS. A quick overview of, you know, of Industry 4.0. Again, we can only kind of skim, and we'll have a Q&A at the end of this, but you can kind of only skim the surface of what 4.0 is. And basically, sorry, it's easier to read over here for me. So a cyber-physical system is imagine your factory that went to, you have all this automation, all these work cells, different areas, but they have no idea really right now, softly they do, what's happening between them. Yes, they're integrated and you have large factories and all this stuff, but how well are they truly tied together? What I4.0 does in the CPS systems is takes another acronym, IoT, takes devices and creates cyber-physical systems. You have many cyber-physical systems within a factory. Those many things create a smart factory. That smart factory then expands into a whole logistical chain management process and kind of goes down the stream. And what people are talking about in the future, we'll get into, but it's many small systems that are much more flexible, they're smarter, they communicate well, and they react quickly. And as Andy said, the millennial generation, and just in today, people want to go online, they want to get a custom shirt, tailored to them, they want it delivered to their house, they want it to be theirs, right? They want shoes that have their name on it, they want certain things. So people are demanding this stuff, and factories need to react to that. And they're doing that via CPS, etc. 4.0. I4.0 came about, you know, Bosch, they're a big, great company. They make washing machines to high-speed packaging machines, right? There were a few gentlemen that created a small board in late 2011, and they basically got together and started talking about Germany is where it's at in the manufacturing scene. You know, obviously they're a great big player. They're not procreating, so they saw this declining population in Germany, and they had issues. They basically said, by the time we get to 2020, what's going to happen is, who's going to run the factories? How are we going to manufacture? How are we going to be a big player in the world of this? As of late, I think they solved their problem inadvertently, but you know, they know that they have to become a successful or maintain their successfulness in the industry. They pulled together the idea, the concept of 4.0, and that's what it is. It's still a concept, it's a theory, I'll say, with some layers in there, the IoT and CPS and et cetera. But in 2013, you can go download the report. They released a report at the Hanover Fair. So at SPS Nuremberg and Hanover, you know, in Germany, you're going to get every 6 months, you're going to get a release of technology, right? So if you want to stay on top of I4.0 and technology in general, that's, you know, you want to watch the Hanover Fair. These guys released it, and it you know, it was probably a 13, 14-page document, came out and, again, set the stage. Here's what we want to do. By 2020, we're going to invest $40 billion in German manufacturing. What they plan to do is, with the $40 billion investment into Industry 4.0, they're going to increase output by 20%. They're going to decrease quality issues by 13%. Net, they're going to obviously gain a lot, right? And doing it with fewer people. So. Intelligence is expanding. We all know technology. Like, I mean, nowadays, I try not even to carry a laptop. This is my tablet because I can't stand big phones. So this tablet can do most things that I need to do in a daily task. It's much lighter, smaller, faster. Technology around us is big. But intelligence is expanding. Feedback control and getting the CPS to communicate with other CPS systems around it is big. So when I say it's expanding, you can go today, buy a protocol called Insteon, Z-Wave, whatever for your house, and for less than $1,000, you can walk into your house and automate it. Is anyone familiar with home automation? Something like this?
Yes.
So yeah, no?
Like Nest.
Net, yeah, similar, yeah. So you walk into a room, because you walked into the front door, it's going to start turning on lights where you decide that it should turn on. It could close the garage door behind you, does all these things. This stuff, again, costs less than $1,000 to completely automate your house. You can track your house from wherever you're at in this office today. You can change the thermostat, you can close the garage door, etc. Raspberry Pis, Arduinos, these little boards are coming out. They're very powerful little systems that people are nowadays, even Bosch, are taking very small processors, putting them into torque limiting screwdrivers and have some pretty high precision tools with embedded controllers. Like it's not Raspberry Pi, but it's considered very similar. You take this component that is the home side of things, the maker side of things. It's a faster pace. People are like developing and cool things are coming out, and you move it into our world, industrious. It's harder to get into the industrial side of automation, but it's going to take similar grids, theories of operation, etc., and move it into this. And that's what people are doing. Different protocols. They're higher power protocols. They're more, but they're using Amazon Web Services, Azure's, all that stuff. You need to receive inputs, send it up to a cloud, send it out, do something with that. So that's the similarities between the two. The intelligence for industrial, anyone that knows me knows that I'm not a big Alan Bradley fan. I'm a huge IPC fan because I feel IPCs are the way of the future. So a industrial controller that is already a Windows-based controller. You're already one leg up on your whole scheme. Let's go pay Alan Bradley $3,000 for a certain card to push information out to a SQL server, blah, 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 blah. So with Beckhoff IPC, you can write function blocks just to push out to a cloud. It's there. I mean, it's simple. There's standard OPC UA code. It's already created. And the computing power is huge. What you're trying to do now with all this information is process it. And to do that, you need PCs. The standard PLCs are not made to process information like this, right? So, and PCs, they just keep getting better and better and better and faster. So, this is another pretty common slide, but okay, what is IoT? It's a layer underneath Industry 4.0. IoT is just the internet. Sorry, the Internet of Things. It's the things. It's the sensing. It's all the sensors. It's all the devices you're tracking. The RFID. It's everything and how it communicates to each other. So you have IoT devices all over your factory floor. They together collectively make a CPS system. All that's under the theory of Industry 4.0. That's the gist of that. Consumers are demanding this, obviously. You want a custom shirt, you want custom shoes, they want speed. People want batch size 1, that's the latest buzzword. They want, basically, again, their customized product. They want it fast, they want it now. So, any way you can buy time, there's a lot of tech companies out there right now. Uber, what's Uber sell? Does anybody know? Right. This is my opinion, but Uber sells time. Like, they basically, they don't sell, their whole theory is, we're not getting you, you know, they're just trying to improve your interaction and get you to be more effective, right? So anything you do, when you're doing all these apps, hopefully everybody's getting these apps and they're not like playing games, but they're apps that help you basically improve your productivity in a day, so you only have so many minutes in a day. How do we do more with, you know, as an individual? You download things like Uber, et cetera, and et cetera. So, again, to the whole Elon Musk thing is, you know, we have to move the needle. You have to make big decisions. You have to like really start at the beginning. Obviously, it's hard for Hershey's or others to clear the slate and say, this is how our future is going to be, but Germany's doing it. They invested $40 billion. Obviously, they have grants and all this stuff behind them to help them do that. The country's, you know, supporting this. So in the U.S., it's a little, it's not as cut and dry. There's no entity in the U.S. that really says, here's the alliance. Yes, we're going to help you get grant fund money to go do this, and you can change your whole manufacturing scheme and your architecture. However, here is the opportunity in the world that, you know, if you were to make the change, you could possibly see this. And it's big numbers, $371 billion. Just kind of expands on this, but basically Microsoft, GE, all these companies are out there saying, I mean, everybody's jumping on, you know, the tech companies, Honeywell, everybody's jumping on these ideas that we need to get into the IoT game, we need to get into the Industry 4.0 game, and there's big wins as far as opportunity. Again, it's the 20% increase opportunities, or I'm sorry, output, 12 to 13% fewer quality issues, more line availability, et cetera, et cetera. Okay, so what's it look like? Here's some acronyms. Get to know MQTT, Azure, AWS, RFID, OPC UA, all these type of things. NFC, you know, there's anything that has to do with wireless technology, we were just chatting earlier, is big. Near field communications, RFID tags, wireless as well. All these are great like tools that help you build out your CPS. Basically, Amazon and Azure, they're building the platform that's called cloud, just another computer. But they're allowing you to connect to a cloud and store all this information. We're doing a project right now. It's an IT project. It's amazing. It's $4 a month for the customer, and they will never ever hit the necessary tags that Amazon says you can send so many messages to through this broker to Amazon and store it. We'll never hit that in 10 years, you know, basically. And it's great value. Azure, similar platforms, just the Microsoft version. MQTT is a client broker. MQ is basically message queuing. That it's a term that IBM kind of started years ago. But MQTT again is just the broker that helps you get into the cloud. So we can chat a little bit more offline if you guys want to talk about where you start with the structure. But you have machine-to-machine control. That happens every day today. Then you have to push that up to a cloud, and you do that through MQTT brokers. You have RFID chips that are out there that basically are, you know, watching a pallet, knows what's on the pallet, make sure it's manufactured to the right specs, make sure that then goes, you know, the future of all this then is it will then follow to your retailer, be on the shelf at Home Depot. Home Depot will know when it's too low, they'll order more shovels for the guys here from Ames. You guys get you know, a message immediately says, hey, our stock's low, we're reaching that point, send us more shovels immediately. Some people have the theory that, you know, you will then go and your coffee machine will basically know when you're low on coffee. All you're doing basically is saying, this is my favorite roast. It'll know when you're low on coffee, it sends out for more coffee, and the coffee just shows up at your door. You have things like Dash nowadays where it requires a human interface. You know, you're just ordering from Amazon. That's going to be automated in the future. So, and you can see where it starts here. I have to make a K-cup in the factory. It goes out through my logistics, and then it comes back from the consumer, and basically the consumer is on-demand manufacturing. So you can understand, I guess, where small flexible lines is almost a necessity, because, you know, you have all these inputs coming in, You're gonna have to capture all this data and say, all right, let's collectively say, let's go make 1,000 French roasts today and go at it. So big subject, big pie chart, security. Just on the phone yesterday, medical, and it was Canadian, so some other like nuances there. But basically, we said, okay, we're gonna push to a cloud that's gonna do this. It was a big fat no. They don't want to push to a cloud due to, security reasons. You have to push to a local SQL server that's in-house, et cetera, internal. It's then you lost control as far as what else you can do with OPC and the whole cloud services when it's within a firewall. Obviously, there's devices to get within a firewall safely and all that, but it's just more and more layers and complexity in your manufacturing design, et cetera. But I can get everybody this link, but if you're to see, obviously, IT is the hub. Like, when you start looking at the structure, IT has to be deeply involved in these conversations. They have to understand what bandwidth you're going to require, what securities are necessary, but they need to be involved early on in the whole scheme of developing this. You can see there's obviously major security breaches through just normal networks. Down here, you have your edge devices, which are like your iPads in the factory, your cell phones. That's the next concern. I have a cell phone in a factory. It's linked to a machine. How do I know someone's not going to go through my cell phone, through the machine, hack into a certain database of that manufacturer? So obviously VPNs, all this stuff is out there, but it's just there's breaches that are coming from cyber criminals, cyber warfare, ransomware. Like it's just amazing. It's a completely different subject, I think, the whole security. But the gist of the story is standardization. OPC UA, they have standard protocols. They know they're already starting it, joining alliances like Smart Factory Alliance. This discussion is being talked about. It's been talked about for years. I mean, so it's a good place to start, just kind of researching and checking it out. So, global overview. Like I said, it's an exciting time now, but in the next even 5 to 15 years, like it's going to be crazy. You can talk to some people and they say that if you don't do this in the next 6 months or 12 months, your company could die. I don't think that's exactly true yet, but technology is moving fast enough. We all remember what happened 1996 to 2001. So then the question is, like, is this a trend? What's going to happen? Is it just going to, is this a fad that's going to teeter out and some people are going to half-bake these implementations? I don't think so. I think something has to happen, and for someone to step up what Germany did and actually create a protocol and some standardization, like, and everybody's just going to follow suit. It may happen. The timeline is I think TBD. No one really knows what it is yet. Germany is very specific. 2020, it has to be by a certain. They're going to try to hit a certain target. This is an interesting slide. It only goes up to 2010, but it shows manufacturing output in the U.S. Obviously, big country. We're producing a lot of things. Then you have Germany. Obviously, China. You have the upswing there. Then you look at this slide. Germany's very focused. They discreetly know that this is the total gross value or manufacturing value add. They know that they are going to continue to be improving efficiencies. So again, in the U.S., I think personally we need to not just gain traction but catch up to